This conference will now be recorded.
Okay. Is it sized correctly? Are you able to see good enough, or should I try and do full screen?
If you can make it full screen, that would be better because it's sort of coming across. Just the presenter mode at the bottom, that would really help.
Bottom right by the volume.
Bottom right, but yeah, button, yeah, you're almost there, a little bit below.
I don't.
Left of the minus sign. Left of the minus sign.
Oh, this one here?
No, at the bottom, where you've got your zoom in and out at the bottom of the page.
I'm not.
Left of the minus sign on the zoom. Left.
Okay.
Keep going left.
Yeah,
that one.
There you go. There you go.
Yeah. I don't know if you see it, but I got the GoToMeeting over the top of some of my my slide deck here. Okay. So I'll start with this and go into the introduction. About 6 weeks ago, we announced what's called our DGX GH200 computer. That was at Computex. Big announcements there on some of our new machines. So just giving you the overview of NVIDIA GPUs, AI machines, and the clusters that we put these into. Although it's a little bit difficult to see in the bottom with the colors, this would be a typical 256 GPU cluster. The dark spot in the middle is actually, I'll call it the NVIDIA leveraged version of the OCP ORV3 PowerShelf. In our world, we typically do N+N redundancy. So there's I'll say an extra set of PowerShelves there, but we work with our different partners and different go-to-market models to support different levels of redundancy from an infrastructure perspective.
Hey, David, sorry to interrupt. You still haven't made it presenter mode. So one way you can help is, can you get rid of the tab at the top where you have all the instructions? So if you do the drop up, if in the very far right-hand side, there's the little arrow pointing up. And if you go to the far right-hand side of the page, that's left, so the right-hand side.
Yeah.
That's it. That little arrow there below your arrow. If you click that.
Yeah. When I do that, does that help your present what you see?
It will. Yeah. If you click that for us.
Okay. Because that actually makes it so that I can't see the. Let me see if I can get rid of this.
I think we might be looking at a different screen than you, because all we can see is your presentation where you would do the editing.
Yeah, and I would try to get rid of like all of the different participants and some of the things off to the side here, but anything I do makes it larger. So okay, I'll just deal with it. I haven't used
or if you could minimize that screen right where everybody is, the minus sign on the top. See on the top, the black screen, which is the GoToMeeting screen, and if you minimize it by clicking on the minus button on the top, see if that helps you.
Try this one.
Sorry to be a pain.
Yeah, we can't read anything, David. It's literally just tiny images for everyone.
Yeah, so I collapse that one, and then the Teams list shows up. Try this again. Nope. View. Try to hide everyone. Can I hide this too?
Let's try just one thing, David, if you may. See at the bottom of your PowerPoint presentation, there are 4 boxes. One is this. If there is the projector sign next to the minus, as Steve was, yeah, on the right, yeah, this one. Click that.
Yeah, click that.
Yeah, click that. Click that. That should really help. See that?
There you go.
Yeah, that would really help.
We got it. We can see it now.
I think it's much better now. Thank you. Thank you, Steve, as well.
Okay. So what's driving a lot of these systems is what's called our Grace CPU GPU combination. We're referring to it as a super chip, and it's a GPU CPU combination. And with this combination, we're doing a bunch of different power controls at the board level. So we also have our NVLink features, memory, so it creates that base that we build into our HPC or our full stack solutions. So in doing some of these things now, although the overall power levels are increasing, we're actually becoming more and more efficient from a GPU and the workload perspective. We're doing power shifting between the different elements within the board, and we're able to adjust via different power tuning mechanisms to control that power better and steer it depending on the workloads and really available power and the performance that's desired out of the cluster. So just, an example here of, different types of CPU, GPU combinations, and looking what we can do with Grace Hopper, which is our newest products, and controlling or steering that power within a provisioned power limit at the individual tray or node level, all the way up through rack to cluster levels. So with the GH200 product that I showed, our average power for that rack is about 30 kilowatts, and typical clusters that we'll be building will be multi-megawatts worth of these clusters. I use the non-redundant number there just because everyone, it's easier to go through and say non-redundant power, and then if you want, n plus 1, n plus 2, n plus n, it really just means more power supplies from this group's perspective, and how you actually set up your infrastructure. And those are some of the things that I work with our different customers and partners on what their particular model will be. As we're looking at our roadmap for next generation parts, we're effectively aligning to a doubling in rack power every generation. So this generation being a 30 kilowatt rack on average, we're looking at 60 kilowatt racks in a couple of years, and going beyond that in a little bit. So looking at, I use my leverage point as OCP ORV3. Now coming into this work group to, with a request, there's been some other presenters that have been asking about higher power supplies, to throw NVIDIA's hat into that ring as well. So leveraging what has been done, there's been talk of 5.5 kilowatt power supplies from our use case. That's another nice number to jump to, along with a lot of the same features. Being able to support the different redundancy models, the wide-ranging individual power supplies, single and dual AC input options, again, single and three-phase options. I have been developing more whips for different customer use cases. So possibly having OCP.
Can people please go on mute who are in the listening mode, please? Thank you.
Thank you, Gary. Along with, I'll say from a flexibility perspective, higher current bus bars and higher current clip options. There are work in all of these areas with, many of the suppliers that are present on this call today. I'll also help to participate in more of this, but would like to ask the OCP community to help me focus the supply base towards a common goal that all of us can utilize. Leveraging what ORV3 had done in the past, and come up with the next generation of higher power shells and solutions. So that's kind of my pitch for today, Harry.
No, thank you, David. That was really a good, and I think we got an insight as to where we have come from, and in fact with your Grace CPU and GPU combo, or what you call super chip, and how we are moving forward. I think it's excellent. And I will open the stage to questions, and I'm sure our participants have, our members have a lot of questions. But I had one question. You mentioned that we are going from a 30 kilowatt average to 60 kilowatt and beyond. And that is really exciting. But where do you see the limit of air cooling? And how do you envision? Do you think that that at 60 kilowatts we will be looking at immersion or some sort of liquid cooling?
Yeah, the 30 kilowatts does present challenges for air cooling. Certainly at 60 kilowatts per rack, liquid cooling is the obvious choice to try to remove a large percentage of the heat. Although we enable partners with immersion cooling, not something that we see being mainstream within the next couple of years. Not to be able to deploy at the scale where we're anticipating to ramp up. And that's where jumping to this one, the 1 million power supplies really next year is a reasonable assessment. If things jump, if you look at the news and all the articles about AI and NVIDIA and try to understand, I'll say all of the demands or all of the interest, we can't keep up with it. So it could be, multiples of that 1 megawatt power supply or 1 million power supplies, just based on, additional interest. Everybody's asking about AI and GPU solutions. So I'm anticipating even more demand. And that's another call to the group here to be positioned to, from a supply chain perspective, to support this opportunity.
Hey Dave, when you move to 660 amps, do you for 35 kilowatts, does the shelf then go in the middle so that you're having to run 330 amps up and 330 amps down?
I'll say, strictly speaking, as a power guy, yeah, that's what I want. The middle of the rack is also a very desirable position for all of the network, NVLink, high speed stuff. So it's all, everybody wants to be in the middle of the world. I think the high speed networking offers more benefits at the solution level. So most of what I've been looking at pushes the power shelves to the top and the bottom as close to the compute as I can get it. So that's I'll say that's a detail we're working on. The trade-off.
You also talked about the 200 to 277. Are you guys seeing that in the U.S. you still got a lot of a 208? So you need even larger amperage. Is that what you guys are designing to? Assuming 60 amp 208, and you don't think the world is in the U.S. is going to change to 415 240 anytime soon?
For our customers / partners that do NVIDIA SuperPODs, I won't say that it's a hard requirement, but it is a criteria that we look for when defining the data center sites to be at least the 240, 415, 60 amp service available. So 208 for these size clusters, we don't see a lot of those anymore. Particularly with this type of structure, particularly the 30 kilowatts per rack and multiple rows. The site is already, generally hot aisle containment, higher power allocated per rack. generally that describes at least a 240, 415 infrastructure.
David, hi, it's Harry Soin again. I just have a question. I mean, I'm looking at the screen, and the 3 kilowatt PSUs ramping to 1 million PSUs in 2024 really catches my eye. So essentially, I guess, if you double this, we go to higher power PSUs, of course, the quantity halves, and I guess perhaps that's where you want to go to take advantage of that. So my question here is, as I'm just looking at the next generation. Remember, we are in discussion of defining the next generation specs as we go to a higher power. So, and people have been talking around 5 kilowatts, and I believe you are looking at you're looking at 5.5 because it takes advantage, I believe, of the max whip capacity, right? If I'm taking you there, perhaps you're
Yeah,
implying that.
right. And that's where, I'll call it the sweet spot for most of the
Right.
NVIDIA deployments is that 240, 415, 60 amp drop.
Right.
I do have sites that, are 100 amp and sites that have multiple 30 amp whips. So the ORV3 flexibility certainly helps with a lot of that.
Right.
Honestly, as we go, to a 60 kilowatt or higher rack, 208, lower current feeds, the power whips and the power shelves, the counts that you need just become, it's possible, but when you have just as many power shelves as you do compute trays, that I think our part of the industry can do better and increase our density, because more GPUs is the direction, and looking at how we can enable that from a power perspective.
Yep. So no, that's a good point. Where I was going, in fact, David, was so instead of standardizing at 5, perhaps we should be considering your input and the numbers you have in mind, perhaps 5.5 kilowatt as a limit, not 5 kilowatt or 4.5, which we've been talking about many. So that's why it hasn't been standardized. But your preference will be a 5.5 kilowatt a PSU, correct?
What certainly, and 5.5 has some assumptions on peak versus full load
Right.
efficiency. My desire would be to go push efficiency and squeak every little bit of power out that we can get.
Got it. So I guess we'll work with the power vendors to see, in light of the dynamic load requirements and all the other requirements, where does this number land? Thank you, David.
Now,
So,
and Harry, thanks for bringing up the dynamic nature.
right.
We are doing things at different levels within the power infrastructure. Really, from GPU, I deal with that problem from GPU all the way to the grid. There are, I'll say, different knobs that we'll be able to turn at different levels, but in particular, the AC to DC power supply, the bulk, the capacitance, that's really the stage in a lot of these infrastructures that provides the energy for these very fast transients. And very fast on the 50 volt rail being a couple of amps per microsecond.
Right.
Certainly do want to talk with the supply base about our methodologies for handling that step load in the AC to DC supply. I'll say it's contrary to pushing up the density, but having more bulk capacitance really helps to smooth things out.
Thank you,
Manny, this is John Whitdell. I got one quick question. Are you interested in or thought about the integrated ATS that some vendors have developed? I know you highlighted the N plus N, and I'm assuming that's from the input redundancy side, not necessarily having need for 2N for power supply redundancy. It has some trades off with capacities, but overall can significantly help with overall density by reducing the number of power supplies and power shelves.
Yeah, I've got some background working with the ATSs in the front end of these, of similar supplies. There are certainly a lot of details that need to be worked out. If you're using in-rack BBUs, and you set up your infrastructure and your timing, how you switch with that ATS, that is a solution. I won't say issues, it's just the industry being able to put large quantities of lithium ion into the white space. Your data center has to be designed to handle that. And looking at particularly NVIDIA's customer base, colos and different data centers don't always have that ability to put lithium ion in the
Right.
racks.
Yeah, so the solutions I'm referring to doesn't rely on the BBU. The ATS is actually integrated into the power supply and utilizes the bulk capacitance to provide that hold up. So the power supply themselves are dual input. And it's some offerings from some of the power vendors out there, but not part of the standard. So that's kind of what I was referring to. So it wouldn't have the BBU requirement or bringing in batteries and so forth. So, but it does, since it is integrated in the power supply, it does have impact on, capacity per supply. It's kind of a trade-off.
Yeah, my experience with using just the ATS version, depending on the infrastructure, if you're switching multiple megawatts from one feed to another, within the, I'll say 10 to 20 milliseconds of the holdup time of the power supplies, that's a significant hit on the upstream infrastructure. In the past, when I'd done that, relying on the BBUs to provide a longer holdup enabled you to soften the blow to the utility you were switching to.
Gotcha. Thank you.
So David, Gian speaking from Delta. I have one question. When you are looking for the 5.5 kV PSUs, what is your GPU load? Let's say the pulse requirement.
It's very similar to what was utilized in the definition of the ORV3 pulses. That would be, for this audience, that would be one of those details that we would have to go into separately, just because for this work group, NVIDIA does not have a CLA yet.
Okay, because it's really significant for the magnetic parts because of the saturation. That's why
Yes.
I'm asking, because it's a huge step from 5.5, and if you have 150%.
Yeah.
Okay, but
And
maybe you can work more on the load profile and share with the community.
Yeah, and that is one of the reasons why NVIDIA design clusters are N+N in power. We don't, in our designs, we don't see the 1.5 peak the same as anyone who would use like a 5+1 example. So that goes back to my comments about the AC to DC supplies, the bulk capacitance, and the smoothing effect that effectively more supplies have on the pulse profile presented to the utility.
Okay. Yeah.
But these are all things, from a community perspective that I want to highlight and discuss. Is it, again, going back to my earlier comment about I want to be able to put more GPUs in the rack. So all of these things in my mind are discussion points. If I can smooth out the pulse a little bit more so we don't, I'll say need 2x the power supplies, that's room for more GPUs. My whole goal is to put more GPUs in a rack.
Okay, got you. Yeah, thanks.
You're welcome.
David, this is Sam Abdurrahman from Infineon. You mentioned that with for 60 kilowatt in the roadmap, the liquid cooling will be needed. Were you referring to like direct or a single phase or a two phase? Can you maybe comment on this, please?
I can't offer a lot of details there, but it would be, you know, liquid cooling direct. We're working through with a number of partners to understand, you know, if we do something at the GPU level, what are the compatibility, you know, the liquid, the type, the metals. There's a lot of nuances to work through there from a compatibility perspective. And that's really why I can't comment about a lot of that right now. Just to say we want to bring, you know, just like everybody else, we want to bring liquid as close to the GPUs and keep them cool. But doing that again in an industry favorable way. You know, we want everybody to be able to leverage what we, you know, do as a roadmap and as a demonstrator for our products. We want everybody to be able to use that as quickly as possible.
And one more question. I think in one of the slides there was the input as single phase or three phase. So do you also foresee the power supply to go to a three phase, like a Vienna PFC, for example?
Potentially as a future roadmap. From at least in my personal experience, the true three-phase power supplies are still a little bit more expensive, and you know, also the methodology that's been applied in ORV3 is very effective. If a three-phase power supply could address some of the other, you know, the pulse loading or, you know, hold up, if there's other advantages there, I'm certainly interested in discussing it. But cost per watt is another parameter to monitor.
Okay, thank you.
Well, I'm certainly willing to stay on and answer more questions, or, you know, certainly can reach out to me at NVIDIA, through LinkedIn, through Harry and the team here. Certainly happy to engage more and looking forward to it.
David, thank you. That was really informative, and I think, you know, really appreciate you sharing this, and you know, so this gives us a lot of help and the direction as to where you guys are going. So, any other questions for David? If not, David, thank you. Really appreciate it. Steve, is there anything else you want to bring up?
Just obviously, I think everybody here will be aware, but we have the Global Summit in October this year, from the 17th to the 19th. So, you know, if you haven't already, please make sure you register, and we would love to see you there, participating in the workshops and obviously at the show. So, yeah. Other than that, Colin, did you have anything?
No, nothing for me.
Yeah, okay. Okay. Well, thanks everyone, and we'll hopefully see you on the next project call.
Thanks, everyone.
Thank you.
Cheers. Bye.
Bye.
Thanks, guys. Bye.